In this video, we are going to see the minimal polynomials of Galois field 8 with the primitive polynomial x cube plus x square plus 1. So in the previous video, we have seen the same thing, but the primitive polynomial was x cube plus x plus 1. So in this video, we are shortly explaining this obtaining the minimal polynomials, because all the details were discussed in the previous video. So if you have any doubt, you first see that video. After that it will be very easy to understand this this problem, or obtaining with x cube plus x square plus 1. So there the primitive polynomial was x cube plus x plus 1. So Galois field 8 has elements 8, which are 0, 1, alpha, alpha square, alpha cube, alpha raised to 4, alpha raised to 5, alpha raised to 6. Why these elements? What are these elements? What is alpha? And why these elements are expressed in terms of alpha was discussed in the previous video. So how to obtain alpha cube? So put alpha here, because alpha is primitive element which is the root of this primitive polynomial. So alpha cube plus alpha plus 1, that is equal to alpha cube plus alpha square plus 1 equal to 0. So alpha cube is equal to alpha square plus 1. This part was also discussed in depth in that video. Here I am not going to explain it again. So alpha raised to, how to obtain alpha raised to 4, that is equal to alpha into alpha cube, that is alpha into alpha square plus 1, this alpha square plus 1, that is equal to alpha cube plus alpha square, alpha, this is not square, it is alpha. So alpha cube plus alpha cube plus alpha cube is alpha square plus 1 plus alpha. Alpha raised to 5 is alpha into alpha raised to 4, that is alpha into alpha square plus alpha plus 1, this is alpha raised to 4. So that is equal to alpha cube plus alpha square plus alpha. Alpha cube is alpha square plus 1 plus alpha square plus alpha. So this alpha square get cancelled, because alpha square plus alpha square is equal to 0, because 1 plus 1 is equal to 0 in XOR operation. So here plus means nothing but XOR operation, because all these operations are mod 2 operations. So answer is alpha plus 1. Then alpha raised to 6 is alpha into alpha raised to 5, that is equal to alpha into alpha plus 1, that is equal to alpha square plus alpha. Next, let us obtain minimal polynomial with elements alpha, alpha square plus alpha raised to 4. Now, why these three constitute one minimal polynomial? That was explained in that video, so you can check that video. So you will get to know that why these three forms one minimal polynomial. So how to obtain that minimal polynomial? That is equal to x plus alpha square plus x plus alpha raised to 4. First do this multiplication. So that is equal to x square plus x alpha plus alpha square plus alpha raised to 3, x plus alpha raised to 4. Next, multiply this x with all these terms, that is equal to x cube plus x square plus x alpha cube. Next, multiply with this alpha raised to 4. So alpha raised to 4 x square plus alpha raised to 4x alpha plus alpha square plus alpha raised to 4 plus 3 is 7. So x cube plus x square. Now combine the terms, alpha plus alpha square, here x square is there, so alpha raised to 4. Then x, so here alpha cube, then alpha raised to 4 plus 1 5, 4 plus 2 6, plus alpha raised to 7 is 1. So x cube plus x square, alpha plus alpha square plus 1 plus alpha, because alpha raised to 4 is alpha square plus 1 plus alpha, plus x. Alpha cube is equal to alpha square plus 1. Alpha raised to 5 is alpha plus 1. Alpha raised to 6 is alpha square plus alpha. So here you can observe that alpha and alpha get cancelled, alpha square get cancelled, 1 is remain. Here alpha square get cancelled, alpha square, alpha 1 1. So here 0, here 1. So answer is x cube plus x square plus 1. So this is one minimal polynomial. Next, minimal polynomial with elements alpha cube plus alpha 5, alpha raised to 5 and alpha raised to 6. Now why these three constitute one minimal polynomial? That was discussed in that video. So x plus alpha cube plus x plus alpha raised to 5 plus x plus alpha raised to 6. First multiply these two. So x square, x into alpha 5 and next x into alpha cube. That step I have omitted here and directly written taken the x as a common and written it as alpha cube plus alpha raised to 5. Then 3 plus 5 is 8, that is alpha raised to 8. Then this bracket. After that multiply x with all these terms, so x cube, x square, and here x. Then alpha raised to 6 with all these terms, so alpha raised to 6 x square plus alpha raised to 6x, alpha cube plus alpha raised to 5, and this is 6 plus 8 is 14. Now alpha raised to 14 is equal to 1. Now alpha cube is alpha square plus 1, alpha raised to 5 is alpha plus 1, alpha raised to 6 is alpha square plus alpha. Next alpha raised to 8 is nothing but alpha. That was also discussed in that video, that why alpha raised to 8 is equal to alpha. Then alpha raised to 9 is alpha square and alpha raised to 11 is alpha raised to 4. So here alpha square get cancelled, alpha get cancelled, 1 get cancelled, so here 0 is there. Here x alpha square, alpha raised to 4 is alpha square plus 1 plus alpha. So here alpha get cancelled, alpha get alpha square, only 1 remains, and alpha raised to 14 is 1. So answer is x cube plus x plus 1. So this is another minimal polynomial. So minimal polynomial with 0 is x, with 1 is x plus 1, with alpha square alpha raised to 4 is x cube plus x square plus 1, and with alpha cube alpha raised to 5 and alpha 6 is x cube plus x plus 1. So the broader version of this example was in the previous video. So here shortly we have explained the same problem, but the primitive polynomial is changed. So that is it for this video.